Let's look at some important connections we can make from the previous examples that we did. When we're solving polynomial equations, we'll use the same techniques as solving polynomial functions. The degree n of a polynomial function means it will have exactly n zeros or roots or solutions, or however you want to interpret that, when we include and count those repeated or multiple roots, when we count those separately. So the nth degree tells us exactly how many zeros. Solving equations, we'll use the same technique that we use for solving polynomials. When we have a degree of n, that'll have n zeros. It means we'll have exactly n linear factors. Each zero gives us a factor. Finally, when we saw those imaginary zeros, we saw that they will always occur as a pair, in a conjugate pair. 2 plus 5i has to have a pair 2 minus 5i. So if I told you I had a polynomial that was, let's say, 4th degree, and it had this list of zeros. I've only given you a list of 3 zeros, 2, -4, and a 6i, but I've told you it's a 4th degree. You have to infer anytime you're given an I, or a zero has an I component, even though it's not given to you, you must know that he has a partner. If it's not given to you, you need to include his partner, which would total 4, which is what we would expect for a 4th degree polynomial. Keep that in mind. You might not be given all the zeros. You have to infer about that pair that goes with the conjugate for the imaginary zeros. Last thing we're going to do is sort of go backwards. Can you find the polynomial equation if you were given the zeros? Let's take a look at this. I've said, okay, well, this is what I said earlier. Okay, we have a 4th degree polynomial function that has real coefficients, and this is the list of zeros, and that list is incomplete. They forgot to give us one, but we should be able to catch it, because if I have a zero of an I, what's going to be his partner? So let's actually list the zeros completely. -2, +2, I, and his partner, -I. If it's 4th degree, I have to have 4 distinct zeros. Now to go backwards, all we need to do for our polynomial function is set up the factors. Each zero comes from a factor. We've seen that when we've gone forwards. -2 would come from a factor of x plus 2. The sign has changed. +2 comes from a factor of x minus 2. I from x minus I, -I, x plus I. Every zero has a factor, but you have to change the sign from the zero to the factor. Well, I'm almost there. I've got my factors. What I need to do now is multiply these out. And I'm going to group them. If you've got conjugate i's, you want to multiply those together, and then anybody else multiply those. But make sure you at least get the I conjugate zero factors, however you want to say that. Do those guys together first. So I'll just work left to right, first 2, last 2. And we're going to use the FOIL method to multiply those out. Let's see what that's going to give us. The x plus 2 times the x plus 2 will give us x squared plus 2x minus 2x minus 4. Using the FOIL method, we'll get x squared minus ix plus ix minus I squared. Let's clean that up. This is x squared minus 4. This is x squared minus I squared. Let's recall something I mentioned earlier about I squared. I squared will always take the value of negative 1. Anytime you have an I square come up in your foiling stuff, you need to replace it with the value of negative 1. Which gives me my two binomials. First one to be x squared minus 4. This one will end up being x squared plus 1 because of the negative with the negative I squared. One last foiling of this will give us our polynomial to look like x to the 4th plus x squared minus 4x squared minus 4, and cleaning that up to be x to the 4th minus 3x squared minus 4. Now we're not done yet, but look at what happened here. Set up 4 zeros, we set up 4 factors, multiplied them out using the FOIL method, left with those two binomials that we multiplied out at the end. Now if they didn't have this part here that I'm circling, we would be done. But whenever they give you such that, in this case f of 3 is equal to negative 150, that means they want us to find a coefficient of a. Otherwise, we would be done. Let me show you how this works, how we're going to set it up to use the f of 3 equal negative 150 to find this front coefficient, this leading coefficient a. All that means is, and I'm going to come and do it over here, we're going to set that function equal to 150. We're going to find a, and what we'll do is plug in the 3. This is saying if you plug in a 3 everywhere x, the answer should be, negative 150. Plug in a 3, answer is negative 150. So I'm going to plug in a 3 everywhere I have an x to allow me to solve for the coefficient a that's in front. So I'll have 3 to the 4th minus 3 times 3 squared minus 4. Working on solving for a. Let's see what we end up with in the parentheses. 3 to the 4th is 81. 3 times 3 squared is 27 minus 4. Now you do the arithmetic. Let's clean that up on that side. (81 minus 27 is going to be what? I don't know. Figure it out. Well, you're probably already there at the end. So I want to just do (81). This is pathetic, I know. I know my brain can think better than this calculator, but not today. Well, forget the calculator stuff. This ends up being 50. And to solve for a, we'll just divide both sides by 50. And we come up with a value of a equal to negative 3. That means our official polynomial function that we were trying to find, f of x, has a negative 3 over here for a. So negative 3 gets distributed to give us a negative 3 x to the 4th plus 9x squared plus 12. So I distributed negative 3 to the x to the 4, negative 3 to the negative 3, negative 3 to the negative 4. That would be our final answer. Now these can get awkward, but it's not too bad. For this last one, I just want you to set up the polynomial function. I don't want you to worry about the leading coefficient, but we can set it up and multiply it out. Let's just practice that part of this. Third degree, and here are our list of zeros. Negative 3, 2i. They didn't tell us the third one, but I know it has to be a negative 2i. Let's take it and set up the factors. 3 zeros give me 3 factors. These are linear factors. So I'd have an x plus 3, x minus 2i, x plus 2i. Remember, from the 0 to the factor, the signs change. Well, with those linear factors set up, we can now multiply out our factors. Always do the imaginary pair first. We'll come back with the x plus 3. So the x minus 2i times x plus 2i will give me an x squared plus 4. Then if I finish multiplying that out, I'll have an x cubed plus 4x plus 3x squared plus 12, which I would prefer to have in descending powers. To look something like that. When you don't have to find the coefficient up front, it's a little bit easier. That would be our polynomial function that has this list of zeros. So work on the course compass homework. You can look at the one in the book. Make sure, though, in the book you look at the applications, technology, and critical thinking, because those are not in course compass.